All right, everyone. Welcome back to Comp 290. This is lecture 4, which means that it is the 4th week of the semester. Congratulations, you've been here for nearly a month back, which is a little hard to believe. So hopefully it's going well for all of you. We are going to be moving into a new module today. So the first module that we are talking about, which is lectures 1 through 3, we're focused on the shell and the command line, as well as we snuck in a little bit of Docker in there and in lecture 3. So a bit of a review. Actually, before that, I'll go over some announcements because it's the first slide. So the first thing is the assignment 3, which was the Docker assignment, will be due, I believe, on Friday night. Except we always put the deadline at 5 a.m. in case there's somebody who is working late in the night for whatever reason. You don't have to feel stressed about getting it in by 11:59. So we set it to 5 a.m. I think if you're working on it from like 11 to 5 a.m., it's probably good to get some sleep. So 5 a.m. is it. So that I think be Saturday. Let us know if you have any questions. We're probably going to try and open another discussion forum on Canvas. So if you have questions about that, we can help to answer those there. And that way your classmates are able to see any questions and maybe get theirs answered as well. The second thing is you probably saw this in a CS department email if you're signed up for that. But there is a career night tonight from 6 to 9 p.m. I believe in the Union. It is hosted by I think the CS department is helping to host this. There's numerous companies, so if you're interested in potentially trying to find a software engineering role, or if you just want to learn more about what types of jobs are out there, I highly recommend checking it out. You don't have to. It isn't something that's extremely formal, so don't feel as if you're underqualified or that it's not meant for you. They host these usually every year, and because it's September, this is generally the peak recruiting season. Every year is around this time. So if you're interested, definitely feel free to visit. It's open for almost 3 hours, so even if you have something to do, you can still stop by.
And going off of that as well, I don't know if you guys have seen this, but on Handshake as well, there is another career night sort of thing tomorrow called Science and Tech. It's not actually through the CS department, and it's in, I think, Rams actually, like sort of down there on South Campus, but that's also a really good opportunity because what you'll find, I think, if you go to this one tonight is that the CS ones typically get very packed out. Sometimes it's hard, you have to wait in line for a while. But these other ones that are sort of more science and tech adjacent but aren't officially through the CS department still have a lot of like CS opportunities, but aren't as packed, so you have more face time with recruiters and stuff, which is really good. So check that out on Handshake if you go on there and look for like a career fair at your school. I think that's the section they have. You can register for that tomorrow. And on top of that, we'll also, after class today, we'll be having sort of like our little hour of office hours. I'll be around for a while, so if you're having any issues with assignments or questions in general, I'll be here for that, and Ajay may be as well.
Yep, and also one thing, I guess as Noah's talking about this, it might be good for just to show, so I'm going to go into a new tab here. If you go to cs.unc.edu, this is the official CS department course website. And sometimes this is a little bit hard to navigate, but there is a section for careers. So if you go under, I think, student experience, there's a tab called career services. And there's a team of people. So these are 2 current seniors, Kiara and Pooja. There's also Stephanie Johnson, who's the director of career services at our department. And she's often around during the week. So if you have questions, you can, about any career things, feel free to email her or also attend any of, either go to our office or attend any events. You can see that there are group office hours. I guess this is new. I did not know about this. So starting fall 2024, can follow this link. There's emails here. In addition, there's a lot of good resources here, and this is kind of hidden away, but for example, writing a resume. So, writing a resume is something which is difficult sometimes to do and to tailor specifically for the types of jobs that you want. But there are resources here. There's also samples, which is great. So I will open this, and I believe this should take, there's some resume templates. So there's some in Google Docs. There's also if you're in the math department and you've been working with this thing called LaTeX, this is a way, if you're curious how your professors write either sometimes problem sets or exams, they all often look somewhat similar and they're in a Times New Roman looking font. They're using this tool. And so you can also, if you're familiar with this, you can edit your resume in there. They also have a data science one now, which is a new thing for this year since there is a new data science major. So if you're interested in that, feel free. And then there's also one here, which I think will be helpful for a lot of you, which is a pre-CS resume template. So if you're currently in Comp 210 and haven't officially gotten into the major, there is a version which may be helpful for you all. So you can see this is actually probably similar for a lot of you in terms of introductory classes. Feel free to add Comp 290 in there as well. I think that would be, yeah, I mean, I don't know, it might be useful. Yeah, there's an intended here. You can add some other tools, including some of the ones that we talk about in this class, because some of the tools that we talk about in this class are ones that end up showing up in far later classes, and you're getting exposed to those early, so that'll be helpful. And so, if you're interested, feel free to check it out. You just have to go to the Google Docs and create a copy of it and edit it to your liking. There's also, if anyone is interested in research at any point, there's a CV template as well, which is a slightly different format. I think the last thing I wanted to show on this page, so if I go back a few, there's other things, like Guide to GitHub. We'll be talking all about this in a future, I think at least maybe lecture 6, we'll be talking more about GitHub and using it for showing off projects. There's also things like graduate school. I know it's probably early for a lot of you to be thinking about that, but it's something to keep in mind. There's career paths. Software engineering is not the only thing that CS majors do. There's a lot of other things as well. So there is software engineering, but there's other things such as user experience design. This is something that I personally think is really cool, and designing user interfaces and how do you get people to actually use your apps and your projects. Cybersecurity, data science, there's other things as well. And so if you're unsure about any of these and interested in learning more, there's resources here. And finally, I think there's another one which is cool, which is not shown a lot because it's again hidden on a page. Our department actually publishes data about graduation outcomes and where people end up after they finish their major. So you can see there are a lot of states like California, which I assume is standard. Washington, Texas, New York. There are a lot of different where people end up and their salaries, etc. And top locations. You can see Durham, Charlotte, Seattle, New York are the top ones. There's also something called I'm trying to find. There used to be maybe it's here. I think if you click on the image, it brings you to the actual dashboard. So this is nice to see. You can see salaries, also by major type. So between BS, MS, etc. There's something really cool which I hope that's still here because it was there a few years ago, which is let's see if it's here. Okay, so there's industry. So here's some employers information. So you can see Amazon is one of them, Capital One, Microsoft. I'm trying to see, there used to be one for, it might not be here anymore. There used to be one for double majors, which I thought was really cool to see. Actually, it is here. So this is also, if you kind of highlight over some of these, you can actually see what majors people pair with computer science. And so if you're interested in picking up a second major or a minor, this is also quite useful. So you can see that this is a pie chart of all the people who graduated last year and what their majors are. So you can see that there's a big chunk of probably almost 2/3 are BS majors, but there's also a substantial amount of BA majors. You can see that most of them don't double major, but there's also some common ones like statistics, math, economics, and you can scroll through and see what people are double majoring in. And so it's just pretty cool to take a look at, and it kind of helps you to see how diverse our student population is here in terms of interests and academic standing. So does anyone have any questions about any of this? All right, so again, this is, I know we went a little bit beyond probably, hopefully won't be too behind, but this career services page, again, I recommend checking that out whenever you have free time. It's relatively helpful for all of those looking at potentially working after college. Okay, so that's all for announcements. Now, some of the things these are two pictures which kind of help to represent some of the things that we have been working on in the last 3 lectures. One has been the CLI and the shell. You've worked a lot with different programs. In the shell, you learned about package managers and how to install other people's programs onto your computer. We use that FZF, fuzzy finding tool, as an example there. And we also talked about Docker. So we've been using Docker for a lot of the assignments indirectly, and then also last week there was a entire lecture by the amazing Noah about Docker. So another thing I wanted to point out is a Stack Overflow developer survey. Has anyone heard of Stack Overflow before? Yeah, a lot of you. So Stack Overflow is a common destination for CS majors trying to find out why their code is broken. But at the same time, there's also it's also a site where a lot of developers can gather. There's a very cool thing called the developer survey. And the developer survey is sent out to developers who are using Stack Overflow, and they help to talk, and they basically talk about the things that they use in their everyday work, such as different technologies, programming languages, different tools, etc. And as you're learning, especially if you're trying to figure out, what are the programming languages which are commonly used? Like, what should I know in order to, for example, get a job, or what should I learn to create new things? This is often a page which is really helpful because it allows you to see what is out there and what is very common. So for example, in the programming world, or in the programming language world, you can see that according to the data, JavaScript and also its TypeScript as well, which is taught in some of the higher classes, is very commonly used. Python is of course, that's what you all learned in Comp 110. It's one of the most popular. You can see over half of the people who responded to the survey are using Python in their everyday work. Even though we didn't directly talk about shell scripting, like actually writing your own shell programs using the bash language, what we have been working with in the shell and talking about the CLI is often a very common place that people are using and working in directly. So that's some information there. And you can see also for learning to code, you can see Python is number 1 there. Over 2/3 of people who are learning to code are using Python. So this is one thing that's useful. There's also, I want to scroll down because there's a specific thing that I wanted to point out. So I think it's under probably, not embedded technology, not other frameworks, but you can see there's a lot of things here. You can see other tools. So you can see these are tools that are commonly used in industry by professional developers, and you can see what number 1 and number 4 are. So number 1 is Docker. You can see over half of developers who are currently in industry are using Docker. So what you learned last week is something that over half of professionals are using in industry. In addition, Homebrew is the 4th item here. That's the thing that we talked about for Mac devices to install external programs onto your computer. So you can see that a lot of these tools are things that people are using. And so one of the things, and the reason why I'm showing this is because a lot of times people go to their classes, whether that be ours, maybe 210 or any other class, and you're wondering, why am I learning this? How is this useful? Are people even using this? Why are we here? And this is some real world data to kind of back up what we are saying is important, and hopefully you'll find that after the course, some of the things that are also covered here in some of these other sections we might be able to get to as well. Also, VS Code is another fun one. 3/4 of developers are using VS Code, and so I'm actually surprised that that's not higher. So VS Code is a great tool. All right, any questions here? All right. Just seeing if there's anything else. Operating system is a fun one. Also AI, okay, this is not part of the lecture at all, but AI is interesting. You can see GitHub Copilot as well. 40% of people are using that. So some of the classes as we move forward, of course in college, a lot of classes are more slower to adapt to some of the newer technologies, but I wouldn't be surprised if in the future some of the use of these AI tools is encouraged. All right, so okay, one last thing, because this is really cool. The admired and desired section is something that I like because it shows what tools people really like, which is in red, and also what people want to learn? Is that it? Yeah, want to work with. And so you can see there's some languages as well. Like Go is one. Actually, no, sorry, not Go. Rust is a language. If you're in Comp 211, they're teaching C, which is a lower level language. How many of you are in 211 right now? Great, yeah, so a few of you. So C is common there. At the same time, Rust is another language. It's a lower level programming language, and that is taking the industry by storm, and people really like it. So as you're going through and going through to 11, you might also be able to want to think about this. But anyway, I will not look at this anymore because there's so much cool stuff here. It will take a long time to get through. But search up Stack Overflow Developer Survey or click on the link in the slides to learn more. All right. So we're now moving towards the content for the next module, which is Git. And so part of the assignment for the last week was to watch two videos. One was 100 seconds long, and then the other was by Chris Jordan, who teaches 110 and Comp 423 here. And the term that Chris Jordan used, and in the video it is abbreviated as VCS, which stands for Version Control Systems. And why would people want to use something like this? Well, if you look at a high level, without ignoring the terminology like VCS and Git, etc., as a software engineer, you're working on programs, and you're very often adding to, like creating new files. You may be deleting from certain files, and also modifying different files as you are, for example, building new features or working on assignments, etc. And throughout this process, throughout the development process, these things may happen. So you could accidentally introduce bugs that you want to undo. Like you may be in a coding session for an hour and then realize that you messed up, and now you have to undo a lot to try and, you're frantically pressing Command Z to try to get to a point where your code was working. There might be a case where you deleted an old file, but you're like, oh, I wasn't using that file, but there's something in there that would have been really useful. Now it's gone. I can't see it anymore. So you would be hoping that maybe it's in your trash can, but sometimes it's not there either. So you might want to do that. I guess that goes with number 3 as well. You may want to delete files, but you might also want to save certain things until later. And finally, there's also chances where you have a working project and you want to explore something new. Like maybe you want to try a new tool or try a new feature. You're not really sure if it's going to work, but you still want to try it. And you're worried that if you start going down that rabbit hole and trying to work on something, you may mess up your project, and so that might be a problem. And so these are very common issues that software engineers face. And the cool thing is that version control systems and Git in general helps to fix all of these problems. And so version control systems are basically just a tool that helps to track the changes of your code over time. So as you work on new features, you may be adding or modifying files, and so the tool is going to be keeping track of those changes. It also creates a timeline, a kind of a timeline is the word to use here. It creates a timeline of your code that you can explore. So you can kind of walk forward in the timeline down to your most recent change. But you can also look at things that you may have done a few weeks ago or a few months ago. And you can also build off of maybe a version of your project in the past. And so when we talk about versions of your project, that's something that we'll be using a lot, and why this is called a version control system is because as you're working on your project over, let's say, a few months or et cetera, every time you may make a new feature, then that's kind of like a new state or like a new version of your project. And so version control systems allow you to see the changes over time, and those changes individually separate your versions of your code.
Oh,
go ahead.
Sorry, yeah, and one other thing, sorry Jay, I don't know if you're going to
go ahead.
this, and we'll definitely get into it in later lectures, but just thinking about this in the back of your mind, VCS, it also allows you to not just work on your own versions, but to collaborate with other people, so people can have multiple versions going at the same time.
Yeah, that's a great point, and that's something we'll be, hopefully you all will be getting to work with a lot in some of the future lectures. Now there are many different version control systems. Git is not the first one. There were many before it. Git is the most common one now. I'm sure if I go back to that survey, there will be like a bar that says 90% on Git. I will refrain from doing that now, but that's something that you can probably check. So Git is the most popular, and using Git, you can maintain and traverse the history of your own code in your projects. Are there any questions with what a version control system is? All right. So now, in order to use a version control system and to use Git, we can navigate to any code project in our directory, so in our computer, and we can do something called initializing. So the word initialize is used a lot in computer science. Initializing is creating like a first version, right? It's like creating the initial version, so initialize. We're going to create what is known as a repository. And a Git repository is basically just a collection of your code that's packaged kind of in one system, where all of the code that, the history of your code for everything in a certain file is then tracked. So like if a Git repository is on a folder that says photos, then as I add and remove from that folder, Git will keep track of everything that's like any changes that are happening with that folder, because that's where the repository is stored. And so I'm going to jump into a short demo here by kind of creating a blank repository. And feel free to follow along. You can actually do this with anything. So feel free to choose a folder, whether that be a homework folder, maybe any even code if Comp 110 isn't using this, or didn't use it, maybe you can jump back to one of your old projects. I'm going to jump over to the terminal here. So I'll kind of give everyone a second to get there. Of course, all of the code actually, especially in this lecture, a lot of the stuff will be written on the slides too. So if you are a bit unsure about where to go, you can follow along with that. All right? Everybody good with having this open? Great. Okay. I'm assuming that this is the same on Windows and Mac. I think that was the wrong assumption to make 2 lectures ago, but it should be the same here. Yes. So I'm going to first, so I'm in my home directory, and I can do ls and pwd to prove this. You can see I'm in my users folder, and here are all the folders on my computer. So I'm going to jump into 290, but feel free to go into any folder you like. So I'll do cd to change directory into comp 290. And now if I type in pwd, you can see we can prove that we're in the 290 folder. And I can type ls, which now shows me the 3 different files that are inside of here. So, or in this case, for examples and ls03, those are directories. But then files are like hello-world.txt and hello.txt. Okay. So what I'm going to do is I'm going to create a new folder. So this is actually something which I don't remember. I feel like, yeah, maybe, I guess we may have not done it. There's a command called mkdir, which is shorthand for make directory. So you can kind of imagine that you're in this 290 folder. I want to create a new folder, let's say for lesson 4. You could type mkdir for make directory, and then after that the name of what your folder or what you'd want the folder to be named, and then it will create it. So I can say mkdir or make dir, and then let's just say ls04 for lecture 4. Okay. And now you'll see that no output happens, except the task has been done successfully. And I can prove that by typing ls. And you'll see now that ls04 is a folder that is marked here. And also, to kind of connect to, sorry, not lsa. Okay, this is that lsl command that we talked about last time. And you can also see that, remember how that first character, if it's a D, that means it's a folder. So you can also see that this ls04 has a D here, so it is in fact a folder, or it is in fact a directory. That's just a connection from one of the past things. Right. Now this is very messy, so I'm going to type in clear and press enter so it's easier to see. And I can now change into this directory by typing cd ls04. And so now if I find my working directory, you can see my working directory is now within this folder. Okay? So at this point, I'll let you choose any folder. We're going to create a Git repository with this folder. And so again, any folder on your computer you can do it with. I'll just do it in here. I can type in the command git. And if you installed Git, which was part of the homework, then I think every computer should automatically have it. But there's been some cases in some classes where some computers don't have it for some reason. So it's always good to check that. If you don't have it, if you get an error by typing in Git, feel free to just detour onto the website, just search how to install Git, and there should be a command. And if it's taking a while, feel free to just watch along. We will use the command git init. So remember, init is the term that we're using here, initializing a repository. Init is also a common shorthand used in many programming languages for init. So git init. And you should see, it says here, initialized empty Git repository in, and then this folder. And you can see there's something weird at the end here. We have our ls04, which is the folder that our repository is supposed to be in. But then we also have this folder here that says .git, and that's inside of here. Now, if I were to type in ls, ls is fine. Yeah, so I typed in ls, you'll notice that nothing happened. And that's because there's nothing in the folder that's visible. Yet, you see here that, well, my current working directory is ls04, and there is a folder in there that I can't see. Does anyone remember why we can't see it, by any chance? There's a hint. You can look at the name of the folder. Any guesses? Yeah? Yes, exactly. It is hidden. You can tell that it's hidden because there is a dot in front of it. So remember, that's what we talked about that, I think, two lectures ago. This is a hidden file. So remember that in order to see hidden files when we're typing in ls, we have to use the A flag for all. And I guess on Windows, this is where there might be a difference. It might not be A.
Yeah.
Do you remember what it is?
It might be -H, I think, but on Windows, it's okay if you can't see it.
Yeah, if you're on Windows, don't worry. You could also do it in the dev container, and it will work. But we promise everything in terms of Git will work. This command may not. But you'll see here now we have three items. The dot is the current working directory, which is kind of weird that it shows up here, but it does. Dot is the previous. It's just pointing to the previous, the folder outside of this. So that would be the 290 folder. And then we have this .git folder. And we don't, for the purposes of even throughout most of your career in this department, you'll probably never open that folder. That folder is hidden because Git manages that entirely on its own. So as it's keeping track of the changes in your project as you make them, all those changes and all that data is stored in this hidden folder. You don't have to touch it because you can just use Git commands to deal with everything, and Git will handle it. That's why it is a hidden folder, so that you don't accidentally mess with it. And that, I think there was also some of you on that lecture, and we asked about what are some of the reasons why we want certain folders to be hidden. I think there's a student somewhere here in the front who had mentioned that, well, certain folders shouldn't be touched and messed with. This is one of them. This is one of them. All right? So we have now created a Git repository. And in order to really go any further, I'm going to go back to the slides and continue on a little bit. Any questions here with any of this so far? Okay. So we're going to be talking here a little bit about the fundamentals of Git and how Git works. One thing which I also try to do very, very often in some of these slides is to be a bit intentional about the colors and symbols. So you'll see that under this thing called a commit, we're using a green flag to represent that, and that'll be consistent throughout the rest of this lecture. So the Git history in a project, so when we're talking about a Git history, we're talking about that timeline of all of the changes in your project. From the beginning, from that initial empty Git repository that we just created, and then as we add files to that, that is our history. And history in our project is organized into these commits. And what commits are is that they are basically a snapshot at a certain point in time of your project. You can imagine almost as if you're drawing if you have an iPad and you're drawing some sort of art or some diagram, and you just take a screenshot, like in the middle of drawing. That's like a snapshot of what your art looks like at that current piece in time. That's the same thing here as a commit. So when you make a commit, it's like taking a screenshot. It's like just seeing exactly that snapshot at that moment, at that timestamp, the state of your code in your project. And so this allows us to keep track of changes that are made from previous versions. So there's a diagram here. So this is Chris Jordan over here. He is happily working on a project. And he started off, there's kind of this dotted circle which represents a empty folder. We haven't created anything. And then maybe at some point in his project, he creates a new Python file called main.py. This is probably a little bit small in the back, I apologize. There's also an even smaller key over here, but when you look at the slides, it'll be easier to see. There's a plus for file added, a star for file modified, and then a minus for a file deleted. So you can see that maybe the first thing that he did in his project was create a main.py file. And so that may have happened somewhere along here. So maybe he created a file. But then after he created that file, right over here, he wanted to save his progress. Just like in art, like taking a screenshot, or maybe in a video game, doing a quick save. Kind of the same idea. And so what happens is we place a commit right here, and the commit is going to store all of the changes made from the previous commit, the starting point, up until this point. So you can see that we create a commit right here, and the changes that have happened since has been adding a new file, main.py, and so that commit is going to keep track of these changes. Next slide as well, there'll be even clearer showing this. You'll also notice these fancy like letters here and numbers, and every single commit is associated. When you create one, there's a unique ID identifier associated with every commit that Git creates. And on the next slide, I'm going to talk a little bit more about that. But let's say that, okay, I've saved my work after creating the main.py file, but then he does some more work. So he creates a script.py file, and then he modifies the file that he created. And then he wants to save his work again. So he will create a commit and place it right here. So this is now the second commit. And this is another snapshot of his project. And so you then, if you wanted, and let's say he created a snapshot, and he's like, okay, well, I'm working on something now here. Oops, I made a mistake and everything's wrong. He can now jump back, and we'll show you how to do that. He can now jump back to the previous version of this code and get back to a point where everything was working. And so the last thing here, he modifies script and then deletes main.py, and then he creates another commit. So you can see that commits are basically saving the state of your project as you go along. They're like checkpoints. And the reason why I used a flag here is, if you're familiar with Mario in any way, you'll notice that there's usually 2 of these in a world, and if you run by it, you get the flag, so if you die at some point in the middle of where you got that flag in the end, you end up respawning right here. That's kind of a similar analogy with Git, right? Like you can create a little checkpoint where it's like a quick save, but if something goes horribly wrong over here, you could end up going back to the same place of where you started. So that, I think, is an analogy which maybe for the Mario gamers out there, this will be helpful to think about. All right. Now, I want to talk a little bit more about the specifics of what is actually inside of a commit, because we showed these little goalposts, but what's actually happening? So a commit contains a few things. So first, we have a commit ID. So this is the number and letter combination that we showed here, as well as here, on both of these commits. And this is what's known as a SHA-1 hash. It is 40 characters. And this is not something, I don't think you have to know the specifics about this. Noah, do you have any?
No, just know that it's longer than what's displayed there.
Yes.
But frequently, when people refer to hashes in Git, they'll only use the last 6 or 7 letters letters and numbers of a hash, because that's enough to uniquely identify it. But yeah, it's actually way longer than.
Yeah, exactly. Yeah, great point. I almost forgot to mention that. So yeah, it's like an abbreviation of that 40-character hash. But what happens is all of the other things in your project. So the changes made. So what changes you worked on in the file. What the previous commit was that we just built off of. The author, the timestamp, all of that data is combined in and goes through an algorithm which converts it into a 40-character hash. And that's the identifier. So it's nice that they do this so that if something goes wrong, that identifier can also, it's uniquely made from this data. It's very unlikely that you'd have 2 of the same IDs. You can use it later. There's also something here called the commit message. And what happens is when you are saving your work, you can actually create a message and name, instead of just having the commit have just those letters only, you can write some more description about what has changed since the previous commit. So let's say I started here, I add a script file, and then I modify the main file. I could just make a commit, and it just says modify files, but it might not be too descriptive. And we may want to be more descriptive, because if we're working in a very large project, or we're working with others, let's say that you're working with somebody, you're in the Triangle, you're in Chapel Hill, you're working with someone in Seattle, and you were working at 7 a.m. our time, they were still asleep over there, and you made some changes to the code, right? But then when they wake up, if you just made a commit in your project and there's no description, they may be like, what did this person actually do, right? But if you write a message for it, when they see that a change has been made in the project, they can read the message and they say, oh, okay, that's what happened while I was gone. And so there's a very big benefit here when you're working with others in writing good commit messages. So you can see these are some examples of Chris Jordan writing one. So there's create a main script file. So you can imagine that maybe somewhere over here, I know these words are a bit it's really like saying create the main.py file, which would be somewhere here, and then since then create the script file, and then maybe modify the main file in some way to utilize the new file. Any questions with this? All right. So you'll notice that this is another representation that I'm doing, and throughout this lecture and even the next one, I'm going to be changing a little bit of the ways that I describe these in diagrams, because eventually we're going to get to a point where we get to a more simplified diagram that more in other classes you may use, but we want to start out with something like with flag posts that are very easy to maybe visualize at first, and then work our way into a more simplified version. So you'll notice that these are actually representing the same thing. So you'll see here that this was my first commit. So that's why when we say parents, parents are pointing to the commit that happened before. And if you took comp to 10, or are currently in it, you may have heard of the, you may have used the linked list data structure. It's a kind of a similar thing. It isn't exactly a linked list, and we'll see why next week, why it's not just a straight line. But you have the same idea where you have like one item and it's referring to another through a address. And so this is because in the way that it's managing these Git files, it doesn't have a very neat diagram drawn somewhere. There's all these different independent files, and you need to be able to point to different ones. So this commit was based off of this one. So you can see f1ac ... That's the ID of this commit. It's used as a parent over here. There are brackets there. Again, we're going to get to that next week as to why there's brackets and not just a regular thing. But I guess if you're used to in Python where brackets, remember brackets are a list in Python, and so that might kind of help ring a bell. So okay, maybe next week we might not just see commits with just one parent. But for now, you can just assume that there's only one. Author and timestamp are also included, the commit message, and then any changes that actually happen, these are also kept in a commit. Because if you look at this, in order to see what changes we made, let's say we're here, this is where we're currently working, and we want to see the previous version of our code. In order for Git to change our code back to the previous version, it needs to know what changes happened along the way, and so that it can undo those changes. And so that's why the changes are also kept in the commit. Now, it's not just written like this. This is very simplified. We're just create script.py. That's not actually, it's going to have a lot more data as to every single line of code that was changed, what was added, etc. This is just an abbreviation so that it fit on the slide. Any questions here?
How's everyone's understanding of what a commit is right now? Can we get a thumbs up, thumbs middle, thumbs down?
Okay, good. Like it. And what do I want to do here? I think we'll jump into the example again. So I'm going to clear. So we have an empty Git repo. Oh wait, question? Yes. Is it a technical thing? No, if you want. There we go. All right. So yeah, if at any point you have something's going wrong, feel free to raise your hand, and we'll be able to send somebody, namely Noah, over to help. Okay. So we're in a blank repository here. And this is kind of, if we go back to our diagram here, this is like our initial state, right? We have nothing so far. And we want to make some changes. So what I'm going to do is I'm going to create a file. Now, this is, I don't remember, again, if this was taught in lecture 1. It's used in I think if you read the reading that Chris Jordan did, it was used there. But this should be quite simple to show. So let's say I echo Noah's name, right? So if I say echo Noah, and I press enter, you'll see that it prints back Noah, right? The cool thing is, though, in our shell, we can actually redirect our output into files. So if I say echo Noah and that prints out Noah, instead of just printing out Noah to the console, I can actually take the output and save it as a file. And so to do that, we use these two greater than symbols. And so what we would do is we would say echo Noah. And so this command is going to print out Noah if I were to run it, just like above. But instead of just printing it out, I want to redirect it to a file, meaning that this text, Noah, instead of just being displayed here, I want to save it somewhere. So I can type in two greater than symbols here. All right? And then after this is going to be the name of the file that you want to create. So the example here I can use, for example, is, goat.txt. This is a new file that I'm creating. And I'm taking the text there, and I'm saving it to this file. So it's taking the output, redirecting it, and saving it to a file.
And hopefully this is a callback to the first assignment with the command line. If you remember, there's one use of this. I think at the time it was only the one greater than symbol, but the same ideas of just output redirection.
Yeah. And so I think the difference is that 2 creates, right? Or it's like overwrites a file if it
Yeah, one
existed.
will overwrite a file if it exists, and 2 will append to it if it exists.
Yes, there it is. So if I press enter, you'll see that nothing happens. But if I ls now, you'll see that a file called goat.txt has been created, and it's now inside of my folder. Okay? Now, remember, we can use the cat command to print out the contents of a file. So I can type in cat goat.txt, and you'll see that Noah now shows up because this is the text inside of this goat.txt. And I guess to just double down and prove my point, I can go to my folder. So, sorry, I don't know where this is. I think it's home. comp290 and ls04, and you can see there's this goat.txt file where if I increase the size of this, you will see that Noah is there. So we've created a file entirely from the command line. There's some crazy and really useful ways that you can use this redirection technique. Here we're just creating a goat file, but you can do many cool things with this. In fact, using that, I think you could even chain if you want to try at home. The FZF, remember when we did FZF, you can search for a file and then press enter, and it printed out the file path. You could do something like that and then try and redirect it to a file and see if the file path gets saved there. But that's another thing. All right. So now if I were to type in git status, so actually I'm going to clear my terminal first so it's easier.
And on Windows, the command is cls, not clear, so same thing.
Yes, thank you, Noah. Git status is cool because it tells us the current state of our Git repository. And you can see here that the first thing, we have no commits. So we have done no commits yet, we've saved nothing. And we also have this thing called untracked files. So this means that this is a file that we have created, but we haven't basically told Git that we want this to be part of the next commit that we make. And so to do that, we need to add the file. So we can type git add, and then the name of the file. So there's 2 ways to do this. You can either just type the name of the file, like goat.txt, but you'll find in a lot of tutorials, because you probably have a lot of files that you're trying to add to your Git repository, you can instead just use dot. And remember that dot is the current working directory. So if you put a directory, it's going to just take everything inside of that directory and add it to Git. And so we have git add dot, and this will add all of our files. So if I were to press enter and type in git status again, you'll see that now we have changes to be committed, new file goat.txt. So this is something which is really confusing for a lot of people at first because we're using this add command. So a lot of people think add is actually creating the commit, but those are 2 distinct differences where when we use git add, we're essentially, if you want to think of it like a draft, like maybe an essay, and you are like maybe working on, you're like writing an outline on one file, and then you have your final essay, and you like start copying and pasting things over into your final essay. That's kind of the same thing here with git add, where whenever we are creating a new commit, we kind of have this blank draft, and then we need to start adding files to it. So all of the changes that we make, we need to add it to our currently blank commit. And so with git add, that is what we are doing. So just imagine you have like a blank sheet of paper, right, which is your commit, and then I want to add this change that I made to this commit to save. So you say git add, and it's going to add all of that to a blank commit. Okay, any questions about that? All right. And then the last thing is to actually, now that we have this file, to actually write the commit. So maybe we're now done writing, we're done drafting up our commit, and now we need to save it. So to do that, we can use git commit, which will create a commit. Now, this will create a blank commit, but we also want to add a message. Remember, we want to try and add a message to it. And so to do that, we can use the M flag followed by text. And so in here, this is going to be the commit message. This is my commit message. Yay. Okay. So that is maybe the message of the commit that I want to supply. So this -m is basically saying the next thing after this is going to be the commit message. And because there's spaces in this commit message, you want to surround it by quotes. Okay? Now when I press enter, you'll see what happens. It says, now there's a commit. You see there's an ID now, so it's applied an ID to it. We have, this is my commit message yay, and you see one file changed, one insertion, create goat.txt. So we have now saved a commit. And the cool thing is I can write, there's something, I wonder where this is. I'm going to skip ahead past something here. There's this meme that I found along the way in trying to remember what this command was. And so there's a command called Git Log, which allows you to see more details about your commit history. And there's this acronym called like this a-dog. So you add these flags, all decorate one-line graph. So there's this, feel free to save this, make this your wallpaper. So when you're working with Git, you know. But I can type in, so I can go to a terminal. I'm going to clear again. And I can type in Git Log. So by default, what Git Log does is it shows me the commits. You can see there's a commit, there's a long, there's a long string that's a unique ID. I have the author, the timestamp, and the commit message, right? So this is all showing the same things that I showed on the other page. And let's use this long thing. So there's Git Log all, I think it's decorate one line graph. See, when you have a dog in your mind, it becomes maybe a little bit easier after a while to remember what this is. This is really unnecessarily long, so we do apologize for this. So feel free to look at the meme whenever you need to use it. But this is really cool because it actually shows, and when we add more commits to this, it becomes even better because it shows your history, and it kind of makes everything in one line, so it's really nice. So I'm actually going to blitz through something here. I'm going to use echo, let's say Chris, and I'm going to name this prof.txt. And I'm going to quickly run through the steps of git add dot, git commit m, create prof.txt file. And the reason why I did this is because I want to show what this looks like with two commits. So if I were to run the git log again, you will see now that you see both commits in order of how they are recent and then the second most recent. Okay. So let's see. I'm going to go. There's a thing here for attendance check. I'm going to do that in the last 5 minutes just so that I make sure I get through all of this here. Does anyone have any questions before we move on to this? Does anyone have any questions on like any of this stuff? Yes.
So when you're doing echo, what would happen if you did like one arrow instead of like two?
Yes. No, do you want to?
Sure, yeah. The question was if you did the echo command and you used one arrow instead of two, if you could show that command.
Sure.
On that.
Yeah.
Yeah, that would just, so, yeah, this right here, you can actually show if you want to change it to something else, then use one arrow. And now if you cat prof.txt, you'll see it was overwritten. Originally it had Chris in prof.txt, and the one arrow says whatever that file is, like overwrite it, get rid of all the old contents, and just put what I have here into that file.
Yep. Meanwhile, if we use two, so if I were to type in instead Chris now, and I use two, instead of it being overwritten, you'll see that it actually adds it to the end. So like one arrow is overwriting, two arrows is like adding on and concatenating to the end. Yep.
Good question. And also, I would like to say this isn't like Git related at all. This is pure command line stuff.
Mm-hmm.
This is like when you use Git, you may never use the two arrows. That's just how we wanted to create the example files for this.
Yeah. All right. So the last thing I want to talk about here is actually traversing this history, right? So we have this idea of this history that we've created with a bunch of commits. But we talked about the fact, just like in Mario, right? If you die, you end up going back to the old checkpoint. How do you go back to an old commit or an old checkpoint? So the first piece of terminology that's needed for this is something called head. And so there's a label on a commit with this head attached to it when that is the current commit that we're currently looking at. So if you are in a project and you're making commits and you're making changes, where head is pointing to, this is the commits that we are currently editing or currently working off of. And if we wanted to look at a we want to go back in time, go into the time machine, look at a previous version of our project, we are going to essentially be moving this head tag from where we are here. And because this is pointing to where we're currently looking at, then we would want it to jump over to, let's say, over here, to actually look at a certain commit. And to do that, there's this cool command, this git checkout. And we can supply a commit ID, and then head will jump from where we currently are back to a previous commit with that ID. Now, you don't have to write the entire 40-character ID. I think the first few characters will be fine. So I'm going to, so you can see here, this is an example. So let's say we started out there. We were currently working on the commit 9EB2, and we use git checkout 3E51. You see that Chris Jordan, instead of working over here, he's now working off of this commit because he's now jumped. It's like reversing time in the project back to the state of the project when we made this commit. Any questions with that terminology? All right. Now this we'll be working with this a little bit more in the next, especially next week. Do I have time to? I think I'll skip showing it in the command line for now, using our example because it should be the exact same. It should be the same process as what is written here, just so that that's why I shouldn't be going on tangents about the Stack Overflow developer survey. But we'll just assume that we can use this command, and you can even try just using that git like this. I should have it here in my history. Whoops. This, right? Well, I might as well. I'm already here. So git checkout, and let's say I'm currently here. So you can see head is pointing. There's this thing called main. We're going to ignore that for now. But you can see head is associated with my current commit here. I created prof.txt, and I guess if I run ls, you'll see both files are here, goat and prof. And if I were to type in git checkout, and then I use this ID, so I copy and paste that in. C34DE7A, and of course in your project it will be a different ID. And I press enter. Okay. What do I, git reset, right? Ignore that, what I just did there. That's because I modified the file with that one question with the arrows that you gave a problem. Basically saying that, hey, what you're doing is about to overwrite something that you didn't save. That's what it's telling me, but we didn't want that. So git reset just resets it back to the previous commit. So that's a bit of an aside. You don't have to worry about that. But now I'm going to rerun that git checkout command. And you'll see now that it says head. There's this detached head state, which sounds really, really bad. But don't worry about that for now. This is just an example to show you. You'll see here it says head is now at, so head remembers what we're looking at, is now at this commit. And you can see the message of the commit, the one from the past. And if I type ls, you'll see now that only goat.txt is there. That new change with that prof.txt that I added, because I went back in time to a previous commit in my project, that file is now gone, and we just have goat.txt. Any questions?
We can even see that too if you do the one line again.
Yes.
The Git log. There.
Yes. You can see head is now moved from here to here because we're looking at this particular commit. All right. I think we actually should be good on time. So, and we'll be talking about this a lot more in the next week because in next week you may think, okay, so I can jump back to previous commits, right? So I'm here, I can jump back here. What happens if I start making changes while I'm here in this particular commit? So, I jump back, let's say I undo my deletion of main.py, and let's say I modify it and I want to write a commit and save that work, right? We end up in a weird situation where we're now we're diverging off of our normal timeline. If you watch that Avengers movie, it's like the timeline is branching apart. We have our main timeline, and then now we're moving into uncharted territory here. And so this is what we're going to be talking about extensively next week, and it's something which is actually a term I think used also in that movie, branching. So we'll be talking about branching next week. But the last thing I want to do is the attendance check. So it should be open. We're going to be skipping this example because it's just more of the same. And also, feel free to look at this later. This is just how you should write your commit messages. You know, be clear. Don't write it really, I guess, in a way that's too difficult to read. And you know, this is useful because again, when you're working with others, they want to be able to see what changes have happened. This slide we posted though, I don't want to do too much like information overload here, so you don't have to worry about reading all this until later. But the attendance check, this is actually something I would like in the remaining bit of time for everyone to get into groups or in pairs and just talk about it. So on Gradescope, there are a few questions. And this will be open. It's already open until 4, so you still have extra time as well. And it will say 1 point, 1 point, 1 point. It's based on completion. So if you get it wrong, don't feel too stressed about getting it correct here. So I'm jumping into L04 so you can see what it looks like. Let's see. Okay, so it's like this. So there's 3 pieces, like I'm at the root directory, I'm creating a new folder. What commands would I need to do this? And this is kind of rehashing some of the things that we talked about. So we'll give the rest of time for everyone to talk through these. Don't feel too rushed. Only get through what you can. As long as you do the first one and maybe the second one, you should be good. Yeah. All right. Come on. All right. This may or may not be working. This mic anymore. Oh, it's on. Okay. So we have a minute here. Let's just go over only the first one. I don't want to rush this too much. Does anyone have any thoughts for this particular question? What commands we may need? Yes.
So you just start with make directory 1.
Yep.
Then CD 1
Mm-hmm. Exactly. So what he said is exactly what we did in the lecture. So great work. It's you make the directory first with mkdir, right? You have to create the folder. Then you need to go into the folder with cd, and then you type git in it. And so that creates the Git repository. We'll skip the second one. The answer is actually here. It was, because it's a one-liner. And then this one, in order to create a Git commit, what are the steps that would be needed here? Any thoughts? Yes.
Would you start with git add dot?
Yes, great. So that's the main thing with this one. That's kind of the trick here. Yes, git add is the first thing you have to include because remember we're creating a draft of a commit which is blank at first, so we need to add all the changes. So yes, git add dot, and then after that we would have your the traditional git commit command. All right, that is all. I think Noah had one thing.
Oh, yep. Yeah, that is all. How does everybody feel about the content today?
Yeah, thumbs up.
Gauging of thumbs, how comfortable are you with it? Okay.
Let's go.
Cool.
All right.
Good deal.
Yep.
Great work, Ajay.
Thank you.
Ajay.
And homework-wise, did I forget that? I may have forgot that. That's maybe at the end. Yeah, there's going to be an assignment coming soon, but it'll be very, very short. It's basically just repeating what we did here in class with creating a repository and adding a file and stuff. Optional reading will also be posted if you're interested in learning more. That is all. Noah will be here for an hour. I'll also be here for a little bit. If you have any questions, feel free to come up. Otherwise, have a great rest of your week.
Thanks, everyone.